All right, good morning, students. Welcome back. We are starting chapter 5 today, and today we're going to learn about the number E. The number E. What E is E is exponential growth or decay. Exponential growth or decay. Let me give you a visual of exponential growth or decay right here. So this is exponential growth. Okay. Exponential growth. And this is the rate at which exponential growth rises. Now, what does that mean? Well, the number E equals, you won't have to know this, but so that you know where it comes from, 1 plus or minus 1 over infinity to infinity, to the exponent of infinity. Sorry, let me get that out of the way. That is what E equals. 1 plus or minus 1 over infinity to infinity. So exponential growth or decay, it's also continuous growth or continuous decay. Continuous growth or continuous decay. So that's E. Now, the graph I just showed you was this function, and we're going to actually see how to graph it. So example number 1 is graph y equals e to the x value. E to the x value. Now, E actually has a value. E has a value. Now, it's not a rational number, but actually if you put it into Desmos, if you just put E into Desmos, this is what E equals, 2.71828182846, blah, 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 blah. That's what E equals. You don't need to know that. Your calculator actually knows, your calculator knows the number E. So when we're doing functions, we can plug E into the calculator. So if we're going to graph y equals e to the x, let's make a table and let's plug in 0. So if I find E right here. So there's E. And if I do to the power of 0, I get, I should make that bigger. I get 1. So e to the power of 0 is 1, which we already know because anything to the power of 0 is 1. Well, what about e? What about e to the power of 1? What does that equal? Well, we just learned that 2.7 is what e equals. So we're just going to go 2.7. Now we'll check out 2, e to the second power. And that gives us 7.4. 7.38 rounded to the 10th, 7.4. Let's plug in 3. So I have e to the third power, and I get 20.1. Now these are going to go off my chart, so that's good enough for me. And I will make my graph, and I got 0, 1, 0, 1. I have 1, 2.7, 1, 1, 2.7, 2, 7.4, 2, 1, 2, 3, 4, 5, 6, 7.4. So there's part of it. Now, what I didn't do any negative numbers, so let's check. Let's check our negative numbers. So let's go with negative 1. So e to negative 1 power. Now don't forget, this button right here is negative. That's minus. That's subtraction. And this is negative. So I had to do e to the negative 1. I get 0.367. So I'll just do, since we're getting smaller, I'll do to the hundredths. So we'll go 0.37. Now, how about negative 2? What is negative 2? E to the negative 2 is 0.14. And just so we see the pattern, let's do e to negative 3 is 0.05. So you can see that we are getting smaller and smaller. We're getting closer and closer to 0. Negative 1, 3.7. Or 0.37, negative 2, 1.4, negative 3. So you see it's getting really, really close to this. It's getting really close to 0. Now, the crazy thing with exponential is no matter what I put in here, e to the negative 20th, I get point. So this is a scientific notation, right? E to the negative 9. So I get 0.00000000002. So, I mean, that is as close to this line as you can get. So exponential growth gets as close to 0, but it never actually touches 0. Isn't that crazy? It never touches 0. And we can see this, we just charted, is the same as this, the x value right here. And you can actually see, even though it gets close and close and close, it will never actually touch 0. So kind of cool. Gets close and close and close, but never touches 0. So that's the basic of exponential growth and decay. And now, let's check out a couple more things. So this never hits 0. It never actually hits 0. Last piece for this exponential growth, what is our domain? And what is our range? A domain, what x values do we have? Well, it can go on this way forever. It can go on this way forever. So our domain is all real numbers. And our range is it never touches 0. So y is greater than 0. It's not equal to 0 because it never equals 0. So our range is y is greater than 0. All right, looks good. Now let's check out just a basic transformation of a graph. So this is our parent function, okay? So kind of set that in there that this is our parent function where we have 0, 1, 1, 2.7. So this is our parent function. Let's move over to, let's graph something that moves around. Y equals 3 e to the x minus 2. Now, just that you know how it all works, this simply is our k value. It just moves down 2. So if we have our, it just, everything moves down 2. And then, oops, I'm sorry. So our, this value right here for this negative 2, where this one never hits 0, this one will never hit negative 2. So it's going to go like this. And it's going to go super close, but it'll never hit negative 2. Okay. Now we can plug these all in and make our table and get all exact. But just that you know, our transformation here, we have a shrink stretch, and then we have it moves down 2. So that's good enough to know for how this exponential transfers. Okay. Now, let's look at how we simplify some of these. Okay. Example number 3. How do you simplify if you have e to the 4th times e to the 6th? What would that equal? Well, if you remember from last chapter and the chapter before, if you have exponents, you add them. So this would be e to the 10th. Right? A little reminder, if you have x to the a times x to the b, you get x to the a plus b. If you have x to the a to the b, then you have x a times b. And if you have x to the a over x to the b, you have x to the a minus b. So there's our little side notes right there. So you can put those somewhere so that you have that for all your lessons. Let's do example number 4. What if you have 3e to the 5th and that to the 3rd power? Well, now we're talking about this one. So we have 3 to the 3rd power, e to the 5th to the 3rd. So what's 3 to the 3rd power? 3 times 3 times 3 times 3. I don't want you to go 3 times 3 is 9. I want you to write it out. So we got 3 times 3 is 9. 9 times 3 is, so we have 27. E to the 5th to the 3rd. Well, a times b, right? Because it's exponent times an exponent to an exponent. So we have e to the 15th. 27 e to the 15th. And last, I'll say least, would be 12e to the 6th over 4e to the 8th. Well, now, if you look over here, we've got subtraction. So let's deal with the e's first. So I'll do 12 over 4 and 6 minus 8. So it would either be a negative 2 at the top or a 2 at the bottom. Now, oops, I have an e. Don't forget the e. That 2 is attached to the e. So these numbers are not attached to the 12s. It is only attached to this, right? Because the parentheses here make this 3 go through the whole thing. No parentheses, so the exponent of 6 is just attached to the e. Exponent of 8 is just attached to the e. Now, what's 12 divided by 4? Those are both divisible by 4. So I have divided by 4 over 4. 12 divided by 4 is 3. 4 divided by 4 is 1. E squared. So what does that leave us? The 1. I don't need to write that. So I have 3 over e squared. That's one way to write it. Or you could also write it as 3e to negative 2. Right? Because this negative will make this go to the bottom of a fraction. So 3e to negative 2 or 3 over e squared. Those are your two answers. Okay, last piece. And this is actually where things might be relevant to you. And this is interest. This is banking. These are banking. So you can find out how to make your money work for you. Banking interest formulas. All right, we have two formulas. One is compound interest. Compound interest, and that formula is after a certain time, you have your initial investment. So P is your initial investment times 1 plus the rate of return over the number of times you get returned. Number of times you get returned over total time. Did you get all those? Okay, let me define them. So P equals initial investment. R equals rate of return. N equals number of times interest is calculated. So number of times, like if it's quarterly, that would be 4, like it's 4 times a year. We'll say number of times a year. And then T is total time. So if you leave your investment in for 5 years, that would be your total time. So we're going to look at, so there's compound interest. And let's see. We're going to compare two banks' interest things. So there's compound interest, and then I'm going to show you, let's do a different color. So now I'll show you continuous interest. Continuous interest, and that is A to T equals initial interest, exponential growth, rate times time. So you have RT, so that's rate and time, exponential growth, and your initial investment. Okay? So let's see how this plays out. Okay, so I'll use green. So blue, me, has $4,000 to invest. Dude, I'm balling. Bank number 1 has 4% compounding quarterly for 5 years. All right, 4% compounding quarterly for 5 years. So how do I plug these in? 4%, that's my rate. So 0.04, right? Because a percentage is 0.04. Number of times a year, quarterly. So that would be 4 times a year. My interest is accrued four times a year. And my total time is 5 years. And my initial investment is $4,000. My initial investment is $4,000. So now I just have to plug these numbers into this equation. So let's do it. So my P is 4,000. And then 1 plus my rate, 0.04, over my number of times a year, that's 4. And then I have my N, which is 4, times my T, times 5. So all I had to do is know what was what, and then I could plug it into my equation. So now I have 4,000 equals 1 plus 0.04 over 4 to the 20th power. Now I could totally do that in my head, but I'm not going to. Just kidding, I can't do that in my head. So 4,000 times 1 plus 0.04 divided by 4 to the 20th power. So after 5 years, I will have $4,880.76. So for bank number 1, I will have $4,880.76. All right, sounds pretty good. I earned $880 over 5 years for doing nothing. I'll take it. But let's compare it to my other bank and see if I earn more. So for bank number 2, I have 4% continuous for 5 years. Okay, so that's all I need. So I'm going to plug it in here. So I have 4%. Well, my initial investment is still $4,000. E, and then my rate is 4%. My rate is 0.04 times my time, which is 5. 0.04 times 5. So let's plug this in your calculator. So I have 4,000 times E to 0.04 times 5. $4,885.61. So for this one, I get $4,885.61. So which one is better? Well, this one is better. Over 5 years, I got $5 extra. So really, the gains are nominal. I don't gain that much more, but I do get $5 more. So there's using the number E to figure out compounding interest. All right, your homework is going to be student journal numbers, page 141 and 142, numbers 1 through 13. All right, let me know if you have any questions.